Hello everyone, hope you are doing good and welcome back to my channel. Today we are at problem of the day 9 for the February month for Geeks, and we have again a question on trees. From the last few days as well, we had questions on trees. In a continuous basis, there was some gap, some other type of question on some of the days, but still I would say on a whole it was mostly focused on trees. You might have got a good exposure of trees by now. I hope so, and I'm assuming that you would have also tried this particular question because I've already uploaded the solution you can see in my community post. I've already posted the solution for this particular, question there. If you have not checked it out, please do check the community post as well. Because in case I am not able to, create the video, I will definitely put the solutions here. Because see, solving is a different thing, but explaining it and try to understand what could be explained, and keeping those syntax ready and keeping those comments ready is a different thing, right? Sometimes I do not have time because of my office work, so I post the solution in the community post so that you can go through it, try to understand, give it a try, and then you can let us say for now we are creating the video. Okay, so one thing I will say is that please do not rely on videos. Please do give the questions a try so that at least you know, right, where you are lagging, what scenarios you are not able to code, or what scenarios you are not able to understand, or your code is not able to handle those scenarios. That if you get to get those ideas, then definitely seeing some code will help you a lot. In the first attempt itself, you will be able to understand what your code was missing so that you can take that and complete your own code first, right? That is what is more important. So that is the main aim of creating these videos. Now coming to the question, check for children some property in a binary tree. So see, they have given various things here. I would not like to go through these things. First, let me explain you the solution. That is the question first in simple words. Then maybe you can go through this, the text what they've given. Okay, so as you can see, this is a simple tree. I hope you understand what a tree data structure is. If you're very new to data structure algorithms, then definitely I will suggest you do a Google search on what is tree concept, how it's different from graph, and then come back to this question so that it will help you understand. And again, one thing, if you are good in trees, but if you're new to Geeks for Geeks, so please see these particular things first. This will help you understand what each node in a tree is, what are its data members, and that's how a data structure is created there. Okay, for every platform this will be different. If you are able to understand this particular thing, then you will be able to code the solutions easily. Sometimes it will be given here, or sometimes it will be given in the the other code, which will be below. Okay, today it is given here, as simple as that. Again, the same thing. Now coming to this question, the question is very simple here. As you can see, what we have to check is that, see, for every node, we will have to see if the data of this particular node is equal to sum of the data of its children. That is, for example, this here 35, you can say it is 20 plus 15. Okay, so it satisfies that property. Okay, now coming to see, this is also a parent, right? For every parent, the data member of the parent should be equal to sum of the data member of its children. Okay, so in this case it is 20, right? As you can see, this is 15 plus 5. Okay, similarly this is 15, right? As you can see, this is 10. Yeah, this is the 15, right? This is 10 plus 5. So in this way we'll have to check. Okay, I hope you have got a bit of idea what this question is all about. Let us see the description they have given. So given a binary tree having a nodes, check whether all its nodes have equal value to the sum of their children node. Okay, that's what they're saying. Yeah, return, yes, equal value to the sum of their children nodes. Return 1 if all the nodes in the tree satisfy the given properties, else you have to return and then 0. Even if a single tree children pair, their parent children pair do not satisfy the property, you will have to return 0. Okay, for every node, data value must be equal to the sum of the data values in the left and right children. Okay, consider data value 0 for the null child. See, try to understand what it means is, okay, let's see this example first. See, what it means is, for example, the 4, okay, consider the parent 4. Now the right child of it, okay, there is no right child of it. Okay, so you can call it as a null or none. See, in Python it is called none, N-O-N-E, none. Okay, in other languages like Java or C++, it is called null, N-U-N-L, right? So what you have to do in that case, you will have to consider the data member of that left child, which is not there. You have to consider it as 0 for this particular question. That's what they're trying to say here. Okay, consider the data value as 0 for null child. Okay, also leaves are considered to follow the property, as simple as that. Okay, so that's what we'll have to do. Let's discuss this particular example also. As you can see here, it is 5 here. In the right child of 4 there is no tree, so let us say 0. 5 plus 0 is 5, but 4 is not equal to 5. Okay, so again this is not satisfying the property, as simple as that. Now coming to this particular thing, 1, as you can see, 4 and 3, total sum is 7. Again 1 is not equal to 7, so that those things they have mentioned. 4 plus 3 is not equal to 7, the same thing. Okay, they are mentioning here. Okay, So yeah, that's the idea. As you can see, what they're asking, the time column is going to be often, the space column is going to be of height of tree. So whenever you see height of tree, the two things you can do is see the tree is going to, right. If you have to design a solution which is going to be the height of the tree, there are only two cases possible. Either you have to do a DFS or a BFS. Okay, in either of those cases, the space complexity is going to be height of tree. Okay, as simple as that. So let's see what we can do now. And if you come to company tax, as you can see, it's asked by Intuit. So now let us deep dive into the solution. First of all, let me tell you that if you are good in trees, definitely you should give this question a try. I feel this question is not a hard or something like that. You will have to do a simple DFS, and each attempt you will have to see the sum of the children is equal to the parent or not in each parent child pair case. Okay, so that's what I'm doing. I'm defining a DFS function. Okay, this is the DFS function. Other than this function, I've decided, declared an answer initially one. Remember, we'll have to return the answers in 0 or 1, okay, not as true or false. So in Python, especially in Python, we will return the answer in 1 and 0 only. Okay. So by default, I've made the answer as 1. If I see any case where the sum of the data values of the children is not equal to parent, I will declare the answer as 0. Okay. And that time, the finally we'll have to return the answer. This is the function call to this particular function, and let's see how it works. So initially what I'm doing is I'm making a non-local answer. What it means is, see, this is the answer, right? But in Python, if you are using anything outside of the function, you'll have to make it non-local. Okay, so that's what I'm doing. It's called non-local answer. Do remember, see, these things you will have to understand only if you see in any code editor. If you do not do this, you may not get any error or warnings, but your answer will come wrong, and it will be very hard for you to debug what is going wrong. So if you are from Java or C++ background, definitely you should be doing this. Okay, because these things may not be there in those languages. Okay, at least I don't remember these things being there. Okay, as simple as that. In C++, I remember there's something called a scope resolution operator, but let us not complicate those things further. Okay, if in Python, if you are referring to a variable declared outside the scope of the current function, okay, then you have to make it non-local. Now, if a root is none, okay, that is, if a root does not exist, simply return none. Okay, then if the code continues beyond this, that means the root is not none. Okay, so what I'm doing, I'm declaring sum equal to 0. Okay, I am doing two calls, DFS for the left root of the current parent, then left child of the current parent, and DFS for the right child of the current parent. Okay, the values written by those are stored in L and R. Okay, left will be the value written by the left, DFS function call for the left, child tree, yeah, left child, and R will be the return value from the DFS function call of the right child. Okay, now, as you can see, if remember here, try to understand this case. For example, when the function call happens for 5, okay, as you can see, 5 do not have any children, right? Children nodes. So in both the cases for L and R, both will be none. Okay, this particular code will be executed for both the children of the that is the leaf node. Okay, so they will return none. Okay, it will return none. So both L and R will be none in case, let us say, if the root is a leaf node. Okay, that's why I'm checking. If L is not equal to none, only then add the value of L to the sum. Similarly, if R is not equal to none, only then add the value of R to the sum. Okay, so as simple as that. Remember, if none of these values, let us say both L and R are none, that means the value of sum will remain as 0 only. Okay, they remain as 0 only. But that is not a violation of this property. Okay, see, 5 do not have children, that's why its value is 5. Okay, so we cannot say that this property is not satisfied there. Okay, yeah, this property is not satisfied that. Okay, because it does not have any children, that's why we can't take the sum, as simple as that. So I am checking if sum is not equal to 0, only then go to this. Okay, if sum is not equal to 0 and sum is not equal to root dot data, only then make the answer as 0. So why I'm doing this, try to understand, this code is only for leaf nodes. Okay, in case of leaf nodes, they do not have any children nodes, so they will not have any L and R values. Okay, for them only I am designing this code. Remember, those 5 is the leaf node, still it doesn't violate this particular property, as simple as that. Okay, now this is the actual violation of the property. If sum is not equal to 0 and sum is not equal to root dot data, then it's a violation of property that the parent parent nodes data is not equal to sum of children nodes data. In that case, yeah, if this condition is true, then it's a violation of the property. In that case, you'll have to make the answer as 0. Remember, initially it is 1, but if any such condition is true for any any pair of parent and children, then this particular thing has to be made 0. Okay, answer has to be made 0. Then finally, when we are returning for this particular root, we are returning the root dot data, because it will be children of, see, root has its own children, at the same time it will be children of some other node, right? So I have to return root dot data. Okay, that's what it is, and this is the function call to it. Okay, this is the whole function, and this is the function call to it. Okay, this is the function call. So ultimately, I've written the answer. So if any case exists where this condition is not true, then the answer will be made 0, and finally will return 0 as the answer. Let me quickly run this and show you. As you can see, it is working. I've already submitted the solution and it works. So yeah, friend, that was all for today. If you have any better way of doing things, then please do let me know. We can go through it. And if you talk about the space and time complexity, try to understand this fact. We are going through every node, right? That's why this time complexity is going to be often. And if you talk about the space complexity, try to understand this fact here. In a DFS solution, we are going by CE branches wise, right? So see, there is an actual algorithm involved for DFS and BFS. I will definitely advise you to go there and try to understand the actual traversals happening there. Okay. If you talk about this particular traversal, so what I'm doing is I am first going to the left node, as you can see here. Then I'm going to the right node, and then I'm coming back. Okay, as simple as that. So there are various traversal involved in the trees. You can go through them, and then this will be easier for you to understand how this particular space complexity is coming. Okay, as simple as that. So yeah, friend, that was all for today. I felt this question was on the easier side. Please do let me know your thoughts in the comment section below. And if you like my efforts, if you like to be part of this particular community or group where we share solutions, where we if you have doubts you can ask, and on a daily basis, at least, if nothing but at least on a daily basis, we get a reason to solve the videos, so that we can see how others have solved it. We get to know how others have solved it. At the same time, we get to know that others are also working, so we also have to work. If you want to be part of this community, please do consider subscribing to my channel. It really gives me a reason to continue working, and at the same time it gives me a reason, so it gives me a satisfaction that my code is actually helping someone, let's say not in terms of knowledge or something, but at least in terms of motivation, that they have to know that someone is solving codes daily for me. At least I also have to continue solving them. So at least in that way. Okay, if not in the knowledge way, at least in the other way, that you get a motivation of doing things. Okay, you get a way to do things, as simple as that. So yeah, friend, that was all for today. If you like my efforts, please do consider subscribing to my channel. It really motivates a lot to continue further. Yeah, friend, thanks all, and definitely we'll see you tomorrow.